Okay, so the next problem is problem 3.5, and it says to design the derrick structure shown for a load capacity of 20 kips, so 20,000 pounds. Choose a suitable steel and use a factor of safety of 4. Determine the cross-sectional area for all members and recommend a cross-sectional shape that will prevent any member from buckling. Okay, so we have a shape of our derrick here, and we need to figure out what size structural member to use to create this derrick that has a safety factor of 4. So what might be the plan to go about solving this problem? What do you think? For drawing the derrick in the simulation mechanical software, yes, we want to probably set the bottom left corner as 0, 0, and we can draw our derrick from there. So are we then going to just punch in square inch values until our derrick doesn't fail? Or can we be a little more, yes, can we be a little more purposeful and engineer-like about how we go about this? So how might we go about doing that? What should our plan be? What steps would we take? So we have a known load, we have a known shape and size. What's always the right answer?
Draw a free body diagram.
Free body diagram, right? Free body diagram will set you free, okay? So if you draw a free body diagram of this, then you can determine what the reactions are and what the loads are in each of the members, right? Or the force in each member, right? Because these are two force members, so the force is going to be going axially along the member. So if we know a force, then what can we do? Or what do we have in our toolbox that would enable us to figure out the area? Way back. Probably the first equation you learned, other than physics stuff. Stress equals P over A, right? So we know what our P is. Now, do we know what our stress is? Yes and no. We can define what it is by selecting our material, determining what our yield strength is for our material, setting that as our max, dividing by our factor of safety, and we can say, okay, this is our max stress. We know what our force is. We can solve for our area. So that might look something like this, right? So our given, find, solution, I solve for this. This material is from the solution, and I specifically selected it and specified it for you so that as we're learning the software, I have information that you can compare against so that you know that you're doing it right. Okay, so I mean it's kind of an odd, it's a little hard to read maybe. Where's the material? It's a UNS 10100 steel, which is an AISI 1010 steel, which anyway is what it is, and it's fine. So we can determine what our reactions are with equilibrium, and then we have to do the forces in each member. So what's our means of determining the forces in each member? think
It's
statics,
can't remember the name.
mechanics of materials,
Where you focus on each point at a time.
method of joints. Yeah. So if you forget how to do method of joints, or if you're a little rusty, or if you're lazy like me, then you can go to some software that we have on our computers here in the lab. It's called MD Solids, and I won't demonstrate because it's really easy to use. You can go into truss and figure out how to do it. But I went ahead and put that information into the truss deal so that I didn't have to go through and do method of joints. Gave me all my values. So obviously the largest one is the 113,000. Divide by my calculated, what, 6,500 PSI, and I came up with an area of 17.4 inches squared to start out with. So that gives you a starting point. Now, is that going to be absolutely correct? I don't know. It's probably pretty close. But that way you're being purposeful about how you're determining your solution and not just throwing square inches at it until it works. Okay. So when you're working through these, some of them are a little more defined than others, but when you're thinking about these, think about them in engineering terms and how you would go about solving it in an engineering manner, not just I'm going to draw it, throw in my material properties, and my going to hit the analyze button and see what happens. Okay, that'll get you in trouble eventually. Okay, question.